Good morning, friends. My name is Aniket Kumar, and today I am here to present an exploratory data analysis on the data that we collected yesterday. Earlier, I was skeptical about this data. I thought nobody will fill the Google Forms itself. But later on, when I saw yesterday that so many people have submitted their data, so I thought let's just try how it goes. So first of all, I have imported all the required libraries and then loaded the data set. Now I first checked what is the shape of the data. So I can see here that 175 rows and 5 columns I have. Now to check how exactly the data looks like. So I randomly loaded 5 sample data and I can see here that we have 5 columns: timestamp, height, shoe size, 10th percentage and PUC percentage. Now I basically wanted to run my analysis on these 4 columns. So this column was kind of useless at that time. So I simply dropped that column. And if we run it again, see, now we have 4 columns. Now first thing that we have to check is before starting our analysis, are there any null values? So as we can see, there are 4 null values in 10th marks and 6 null values in PUC. So those were almost negligible compared to our data size. So I simply dropped those rows. And then I checked for what are the data types of our columns. Now for shoe size, it is integer. And for PUC, percentage is also in float, which is approximately numbers only. But this height and 10 percentage, we can see it is in object. For whatever data type, whether it is a string, arrays, list, pandas classifies them as objects. So basically it means that somewhere something has happened which caused our height and 10th percentage to be classified as objects. So first of all, I tried to find out, I tried converting 10th percentage to numeric quantity, and if it finds somewhere error, just convert it into null value. And whatever I am getting from this, I am finding list all the columns which are null and convert it into a data frame and give it to me. So when I run it, so in 10th column, it is in object data type, but there are no string values, I think. There are no null values coming at the moment. So I did the same analysis on height also. And here we can see that because of 2 students, 185 centimeter, they have written some characters over there which caused the entire column to become a string. And now this column, this data basically does, I selected this 9th and 11th rows and I simply updated it into 185, removed this centimeter, that's all. And then I resetted the data type to as float. And if we run it, okay, actually one second, kernel restart. One second. Okay, what exactly I wanted to show you, that if we directly update data like this, it will show some warning. So to ignore those warning, I wrote this code. But when I restarted again, this code got executed first itself. In flow, I simply executed it. So that's why those warnings didn't appear. And now then I checked for correlation. How are our different columns correlated to each other? So this heat map is a very interesting thing. Instead of simply writing df.core, if I have given like this, it shows the data in numbers, which is not quite intuitive in nature. So instead of doing that, I have taken this df.core and I have set our cbound library, which is a library built on top of matplot itself. So to plot a heat map, basically if the color is very light, it means that the number is very big. And if the color is dark, it means the number is very small. So we can see that the correlation between 10th percentage and PUC percentage is high. But the correlation between shoe size and this height, we cannot see much correlation between these 2 columns. So then I run my basic description. We basically did this later on after performing EDA. You will see that how this correlation later on changes when we do some data cleaning and other pre-processing stuffs. So I just loaded how does our data look mathematically. So here we can see that something is wrong over here. Height is 1.59 in centimeters and maximum height is 1000, and even in shoe size, the shoe size ranges from 1 to 69, and in 10% someone got less than 1% and someone got 508%, and over here it's almost okay, but this minimum percentage is again wrong. So I selected all the students whose 10th percentage is less than 40 and all the students whose 10th percentage is greater than 100. List all those students, and these are the columns that I got. And now after looking at it somewhat clearly, I just loaded the entire data into Excel and I saw that these numbers, basically what happens if you write 93 and percentage, Pandas converts that entire data into decimal. So 93% will be treated as 0.93. So this same thing happened here also. So I wrote a function, if the value of x is less than 1, simply multiply it by 100 or else simply return the x value. And I ran this function on both our 10th percentage and PUC marks. And after that I again checked it. Now we are only left with two rows which are showing some problematic data. Now we cannot do anything about them. I simply dropped them. So after dropping them, we are left with 167 rows. And now if I check my describe, now our 10th percentage is coming maximum 99, minimum 55. Here also PUC is minimum 60% and maximum is 99, which is a acceptable range. But now we have to work on our height and shoe. Height is still minimum 1.59. So I simply loaded all the height, anybody whose height is less than 120 centimeter or greater than 220 centimeter. So we were getting a lot of rows. I cannot simply drop all these rows because it is too much of data. So I simply tried to see what exactly is happening over here. And after seeing at it for some time, you will see that it is in feet and inches. Like this is 5 feet 9 inches. This is 4 feet 3 inches. So once again I created another function, if x is less than 7.5, and then I will take the integer part of it, that is 7, I will store it in a variable called feet and then subtract it from 7.5. So I will exactly get 0.5, which will be our inches, and multiply it by 10. So 0.5 will be converted to 5. And this is a basic formula. Around 30 centimeters are within a feet, and you can see it from Google anywhere else. So I ran this function on entire height column, and after that when I again ran this, so this is our data now. So now these are clear cut outliers, which is, I don't know why, but this data is wrong. Now we cannot do anything about it. I will simply drop it. Now 161 rows and 4 columns are remaining. Now for shoe size also, any shoe size which is less than 6 and shoe size greater than 13, I loaded all that, and these were the shoe size, and this data is not as big as height, so we can simply drop these also. Now we are left with 150 rows and 4 columns. Now if we see at the new correlation, now if you compare it with the previous correlation, there was no correlation between shoe size and height earlier. It was approximately 0 itself. But now if we see after data cleaning and few pre-processing steps, we are getting a correlation of 0.49. And then I plotted few graphs, like I wanted to see how many people wear which shoe size. So around 20% people wear 9 shoe size, 23% of people wear 10 shoe size. That's okay, that's similarly. And then I wanted to see if there is any if visually we can see what is the correlation between shoe size and height. So I plotted this scatter map, but I wasn't getting any data, clear cut indication what is the correlation. So I went for point plot. Over here this point mean the point, this point exactly show you the mean height in that age, in that shoe group. So we can see a linear kind of trend is present over here. And then I wanted to see if there is a correlation between 10th percentage and 12th percentage. So I plotted this graph, and nothing clear cut indication was there, but we can clearly see a lot of data is collected at the right top right corner, and it is also visible from this distribution plot. A lot of data is centered toward 90. That's why whether it's in 10th percentage or 12th percentage, a lot of people are present between 80 to 95. That's why we can see from 80 to 95, the density of data over here is more. And then it was just simply for the sake of my curiosity. There shouldn't be any correlation between shoe size and 10 percentage, but still I simply plotted it to see if we can find some interesting stuff over here. But we just failed, I didn't got it. Then I thought let's try with different colors if maybe we can get any clusters that this shoe size group, but there also we didn't got any clear cut indication. Now then I plotted height and 10th percentage, and over here this entire data is over here, but these 2 points, they are looking quite odd, and it kind of gives me an idea that maybe they are outliers. Till now we haven't plotted box plot and all, but still according to the graph it appears to be an outlier. So what I did was height around 142. So I went up again, and over here I listed everyone whose height is less than 142. These 2 people who were causing that graph, and I simply removed these 2 people also. And now if we see the correlation, now it is 0.49 correlation between shoe size and height. After removing those 2 data points, it has increased to 0.51. So, and rest of the things will remain same. Where is the data? Now this was the data. Now those 2 outliers are removed. Then I plotted box plot, and we can see that box plot is saying that in height and shoe size we don't have any outliers, but in 10th percentage and PUC marks we have few outliers. But I didn't want it to remove more data. I thought let's just first build the model and see what exactly, how much accuracy do we get. So I built a model, and now we can see that we are getting R2 value around 26%, and slope, the calculated slope by our model is around 0.45, and intercept value is 43, and this R value basically 0.51. R value is exactly the same thing which you saw over here, this same. So, and then this P value, the more less it is, the better it will be, because the initial null hypothesis is that there is no correlation between our target vector and our feature vector. So if this value is big, that means that null hypothesis is a correct hypothesis. So it is coming around e to the power minus 11. So we are getting a very small value, and the standard error is also around 6%. So it is acceptable. Then I plotted this data, and you can see whatever we checked. So the slope around 0.45, and this intercept 43. Now if we extend it over here, you might think that it is coming around 68, but it is not exactly starting from 0, it is starting from 60 or 50 some. So if you take exactly correctly the x-axis, you will see that the intercept exactly hits the y axis at this 43. Now I started my this data science journey from sklearn, so I kind of wanted to see how does this data perform on sklearn also. So I simply splitted this data into train and test data set, and I loaded linear regression model and trained it on that data set. And here also I am getting a slope value of 0.44, which is kind of same only 0.45, and intercept value was 43, but now we are getting intercept value of 44. You might be wondering why are we getting different values for same model. The answer to it, because we are only training it on trained data set. Earlier in this data set we trained it on complete data set, but before loading this model I splitted it into training set of 118 rows and testing set of 30 rows. So it calculated the slope and intercept value according to those values. Then I simply made a prediction on entire test data set and calculated the R2 score, and R2 score was coming 32%, whereas over here we were getting R2 score of 0.26. So I don't know why, but this model is performing very good at test data set. And then I simply took all these predictions and plotted the graph. You can see that this is the line predicted by our scikit-learn, and this was the line predicted by our SciPy. So both are almost similar. So this was the entire analysis. Thanks a lot.